Good morning students. Today we will discuss very important topic of natural products, that is terpenes. They are also called as terpenoids. So terpenoids are a structurally diverse group of natural products. So they are having a variety of biological functions which have been reported in plant kingdom. So there could be more than 25,000 of terpenoids. So first, under the class of carotenoids, which serve as a light harvesting and light protecting pigments. Second is sterols, which play an important role as the modulators of membrane properties. The phytol side chain of chlorophyll, which is the most abundant organic pigment, is of terpenoid origin. A wide variety of plant terpenoids functions as insect attractants or repellents. They are also terpenoids. Another terpenoids have attracted commercial interest as pharmaceuticals or nutraceuticals like paclitaxel, commonly known as Taxol. It is also a diterpene obtained from a yew plant, and it is also established as a major cytostatic agent, or we can say anti-cancer agent. So lycopene, which is obtained from this tomato, and the lutein, these have been also registered as oncopreventive agents. So another terpenoids, they are defined and classified as a unique group of hydrocarbon based natural products whose structure is derived from isoprene. So isoprene basically is 2-methyl 1,3-butadiene. So it is a 5C5H10. Its molecular formula is C5H10. So another is a very important thing, that is of a isoprene rule. So what this rule states? Isoprene rule states that in most naturally occurring pigments or terpenes, there are no 1,1 or 4,4 linkages. Rather, there is a linkage between 1 and the 4, or we can say this part is considered as the head of the isoprene molecule, and this is considered as the tail. So head always joined with the tail. So 1 always joined with the 4, not 1,1 or 4,4. So there are these three some examples of terpenoids. One is myrcene, another is limonene, the volatile oil. So another is retinol, which is also called as commonly vitamin A. So isoprene rule. Again, a terpene which doesn't obey isoprene rule, this is also called as irregular terpene. So this is a beta carotene, structure of a beta carotene which contains alternate double bonds. So it's a highly conjugated structure, and it gives us a very good chromophore, highly colored pigment, which is important part of our commonly available vegetables, that is carrots or Dacus carota. So if we do the classification of terpenes are classified by 5 carbon units, that is basic isoprene units. So first is hemiterpenes, which are C5 moieties, monoterpenes C10, sesquiterpenes C15, diterpenes C20, triterpenes C30, and tetraterpenes C40. So hemiterpenes, which have the journal formula C5. So isoprene itself doesn't occur free in nature, but several 5 carbon compounds are known which contain the isopentane skeleton, including isoamyl alcohol, isovaleraldehyde, tiglic acids, angelic acids, and butaferroic acids. So all these are terpenes. Basically, these are formed by the joining of the different isoprene units, or the different structures of these particular amiterpenes is as depicted in the particular examples. So next we have monoterpenes. It is C10 moieties. Monoterpenes are the major component of many essential oils, such as which are of economic importance in flavors and perfumes. So common aliphatic examples include myrcene, geraniol, and lavandulol. So open chain structures include many well-known compounds including menthol, camphor, pinene, and limonene. So C10 moiety is formed by the combination of two C5H10 moieties, that is of our basic isoprene units. So two isoprene units can give us these different types of compounds like geraniol, myrcene, camphor, cyanol, eucalyptol, which is available in the eucalyptus leaves, beta-thujone, thujone. Different compounds, different structures are there which we can study in this particular class of the terpenoids. Menthol, carbon, and carene are the other examples. So next we have sesquiterpenes. It is a C15 moiety. Here it is derived from the three isoprene units. That is, C15 sesquiterpenes exist in a wide variety of forms. That is, they include linear, bicyclic, and tricyclic frameworks. So like the monoterpenes, most of the sesquiterpenes are considered to be essential oils because they belong to the steam distillable fraction, often containing the characteristic odoriferous components of the plants. Examples are gamma-bisabolene, alpha-cadenin, pyrazone, caryophyllene, which is the beta-caryophyllene, udasmol, humulene, tetrahydrodantin, santonin, and abscisic acid. Another is diterpenes. Diterpenes are C20 moieties. They are a widely varied groups of compounds based on 4 isoprene groups. So most of which are of the limited distribution in the plant because of their high boiling points. They are not considered to be essential oils because essential oils, that is the volatile oils, they are always low boiling liquids. So instead they are classically considered to be the resins. So the material that remains after steam distillation of a plant extract. So they are called as resin. So the diterpenes exist in a variety of structural types: abyatic acid, alpha-camphorine, inumequilactone, and a taxol, which is obtained from the yew plant, which is a potent anti-cancer agent. Another class is C30 triterpenes. C30 terpenes are based on 6 isoprene units and they are biosynthetically derived from squalene. So they are often highly melting colorless solids and they are widely distributed among plant, resin, cork, and cutin. So there are several important groups of triterpenes, including common triterpenes, steroids, saponins, sterolins, cardiac glycosides. So among these is the azodiractin, which is obtained from the neem plant and is a powerful insect antiphedant. It was first isolated from a neem oil in a year 1985. So other different compounds which come under C30 triterpenes are alpha-amyrin, limonene, ursolic acid, cucurbitacin D, polygallic acid, which is obtained from galls, and the squalane. Last class of the compound is tetraterpenes, which is a C40 molecule. The most common tetraterpenoids are the carotenoids, so widely distributed group of C40 compounds, whereas the structure of the di and triterpenes can have a wide variety of fascinating structures. The carotenoids are generally derived from lycopene, which is a pigment found in tomatoes. So cyclization at one end gives G-carotene and at the both the ends provide B-carotene. So this pigment, first isolated in 1831, is by far the most common of all these pigments and virtually universal in the leaves of higher plants. As it is evident from this polyene structure that the numerous double bond isomers are possible for these basic structures. So all of which can provide us highly colored pigments. So thus in plants, carotenoids, they serve both as necessary pigments in photosynthesis and as also as a coloring agents in flowers and fruits. So this normally results in the colors varying from yellow to red. They are also believed to protect plants for over-oxidation catalyzed by other light-absorbing pigments such as the chlorophylls. So these are different examples of C40 tetraterpenes: alpha carotene, beta carotene, lutein and rhodoxanthine. Thank you.